Okay, so today, as hopefully you all know, since you're here, I'll be presenting a webinar on content analysis, and specifically its sort of application to Atlas.ti, which is a type of software. So this is very much the glamorous part of research, I think, coding data, coding text data. It's certainly something that I've done quite a bit of. All right, so before we begin, I'll acknowledge the traditional landowners. The Queensland University of Technology acknowledges the Turrbal and Yugara as the First Nations owners of the lands where QT now stands. We pay respect to their elders, laws, customs, and creation spirits. We recognize that these lands have always been places of teaching, research, and learning. QT acknowledges the important role Aboriginal and Torres Strait Islander people play within the QT community. All right, so my name is Levi Swann. I'm a lecturer here at QT in the School of Design. And as I briefly mentioned, I've done a reasonable amount of data analysis in my time, certainly spent many, many hours working in labs, coding and analyzing video data and text data. And most of the time, this sort of research that I've been doing has been sort of exploring the relationships between people, technology, the type of activities that they do. So fairly common type of research in the design area. And I assume a lot of you in this space are kind of working in that area as well, talking to people, asking about their experiences, and you're really interested in knowing how to sort of elicit importance and understanding and meaning from the type of things that your participants are talking about. So hopefully today I can give you some good insights into some approaches to that. And also, I guess, different parts of my experience, things that work well and maybe not so well, things that you can try out. Okay, so this session is sort of broken up into two parts. The first part will go for an hour or hopefully close to that. And it'll cover content analysis as an introduction, so what it is and some of the components of it. In the second part, I'll talk about coding schemes and some approaches to developing those. And again, some tips, things that you might want to try or might want to avoid. And then in part 3 and 4, I'll probably jump over to Atlas.ti, the software, and kind of give you a bit of a demo, how we can go about coding in that software, and then what some of the analysis and outputs look like. So hopefully this can be useful, or you can see if these approaches will be useful to your research. In the second hour, I'll be basically a pretty informal question and answer discussion. So if you don't want to hang around for that second hour, that's completely fine, but I'm happy to chat. If you want to show me some stuff, we can talk about it. That'll be a pretty open session. However, the people left over, whatever you need, I'm happy to provide some assistance if I can. All right, so let's get into the content. So we'll start with content analysis. All right, so a content analysis is a basic approach to analyzing textual data, a pretty common approach. And that sort of textual data is anything that has responses to open-ended questions. So this might be things like interviews, surveys, focus groups, could even be audio from video as well. And the reason that we do a content analysis, I guess the first thing is really to apply some structure to that data. So a lot of the data that we get from these open-ended questions is not particularly structured, even though we might ask the same thing to different groups of people. Everyone has different responses and different ways to approach that question and answer. So we want to apply some structure to that so we can analyze it in a rigorous manner. So this analysis usually involves identifying themes or concepts. I'll probably use these words somewhat interchangeably throughout this presentation, because they sort of are in the literature as well. And as well as identify these themes and concepts, we're looking to identify the importance of them as well. So we want to dig a little bit deeper than just identifying. We want to extract some meaning. And we can also do this by exploring patterns and relationships in the data. So how themes, concepts might be related. The content analysis can facilitate qualitative approaches and also quantitative approaches. So it allows us to quantify data with numbers that we can then turn into something more statistical. But if we also want to delve into it and explore the data, we can approach it more qualitatively. Usually you're sort of doing a combination of both of these to identify frequency and occurrence, and then also explaining the meaning in the data. So it's quite powerful in that respect. It's quite important from a research perspective is that content analysis is generally recognized as being effective for making valid and replicable inferences from the data. So generally, if you follow the process correctly, you can explain what you've done with a good amount of certainty, and other people can understand it and then replicate it if they wish to. There's a couple of things that we need before we can go ahead and do a content analysis. These are potentially pretty obvious things, but we need some data, first of all. So I mentioned briefly before, these could be transcribed interviews, focus groups, so on, questionnaires, for example. It's quite important that this data is transcribed, so turned into text, not just audio. It's also a good idea that this is verbatim rather than note-based. It allows you to gain more meaning and also have more certainty. You're also not dealing with that level of bias where, that might be applied to note-taking. The content analysis can also be used for other textual data. So it's been used quite a bit for literature reviews, where you might want to quantify certain concepts that appear in the literature or other articles that you're reading. So it can be used for that too, if you have secondhand data. And one of the main elements or requirements of a content analysis is coding, so the fun stuff. And this is a process of labeling or annotating text data, where we sort of group it into categories, organize it, and apply that structure. So this is that stage of structuring that data. So before we do that, of course, to create a coding scheme, we need to fracture or break down the data so that we can then restructure it or reorganize it. So I'll get into coding quite a bit later on. Okay, so there's two main approaches to content analysis, and these are conceptual and relational analysis. And I'm going to sort of break down each of these over the next couple of slides, just so you get an understanding of what the differences are, what the synergies are, and then also how you might go about doing them. All right, so we'll start with conceptual analysis, and this is also often called thematic analysis, which I'm sure most of you have heard of. And this is because a conceptual analysis is really aiming to analyze concepts or themes that appear across a number of texts. So different interview transcripts, different journal papers, different, any sort of textual data. So we want to be able to identify and analyze those concepts that are appearing. And typically the conceptual analysis involves quantifying occurrences within that data. So we code concepts in the data, and then we see the frequency or the occurrence that they appear. And these sort of concepts or themes could be a number of things. They could be broad issues, they could be specific words, they might be phrases. It all really comes down to your research question and what you're aiming to do. And when we sort of look at frequency or occurrence, we can often look at these in terms of things like total number, probability, percentage. Again, the way that we do this will depend on a number of things, how much data you have, whether you want to all put it in a consistent expression, or essentially what you're looking at with your research. So conceptual analysis is really effective for these sort of first stages of identifying what's important in your data, what sort of themes are present there. It's kind of a univariate style of analysis where you're looking at individual concepts, sometimes in isolation. So it often is limited to describing your data. So describing what is in the data and what are those main themes or concepts. However, that being said, we can of course relate this to different variables. So these might be your participant groups, for instance, age, demographics, anything like that. So you can obviously connect it to another variable. I've put in these slides here to just give you a sense of what it looks like at the end. I think this is often useful when you're sort of talking about methodology to sort of see what the end product is. So this is an example of what a conceptual analysis can look like. So we kind of have here, you know, a figure of graph of different concepts that appear and how frequently they occur, and then some text sort of, I guess, fleshing that out and explaining what's important and why it's important. Another example, this one is less quantified. So we've identified some themes and some concepts within those themes. so kind of hierarchical, and then explaining them, identifying what were the important themes, and then giving examples of them using quotes. So this can be a pretty common way of presenting a conceptual analysis. So identifying what is in the data, and then talking about what it is and sort of fleshing out those themes and what makes them. Okay, so a relational analysis also involves identifying themes and concepts in the text, just like a conceptual analysis. But it's sort of an expansion on what we do in a conceptual analysis. So rather than just looking at frequency, so what's occurring in the data, what sort of themes are present, we're very much interested in the relationships between those themes. So this could be a number of things. It could be, we might be relating themes to specific words in the text, if we want to sort of elicit an understanding of what that theme is comprised of. And again, kind of what sort of relationships you're looking at are very much should be, and like most things in your research, driven by your research question. And a relational analysis is really based on this idea that meaning can be found in concepts that are related and also in the nature of those relationships. So I guess comparing it to a conceptual analysis, it might be difficult to extract a deep meaning from that sort of approach where you're just sort of quantifying concepts and explaining what concepts are present. But if you can start to relate them to other things in your data, then you can start to present some more complex meaning in terms of the themes that you're exploring. So yeah, this relates to these sort of bottom points here. Relationships between concepts give meaning to one another. And it can be really good for establishing things like causality, so something that influenced another thing or preceded another thing. Other relationships as well, such as concepts that might contradict one another. So that's the sort of meaning that we can elicit from a relational analysis. Okay, so I've been talking about a relational analysis, but I guess it's pretty important to identify what actually is a relationship in the data. Now, there's a couple of approaches to doing this. I'm just going to cover one here because it relates quite strongly to Atlas, the software that I'll talk about a little bit later on. So a relationship typically is inferred by proximity, so a proximal relationship. So this is to do with how far apart or how close it is in the data. And in terms of Atlas, I have a little bit of a diagram here with some data, and it has sort of two coded passages. So a coded section here in blue and in red. And you can see that these codes here are overlapping, or these coded sections are overlapping. So these two coded sections of text share a relationship, or otherwise known as a co-occurrence. So that's how we define proximity when we're analyzing the data in the text. You can also, in these software Atlas, as well as things like in vivo, you can establish your own relationships if there is no sort of proximity as well. But I won't be going into that because it's probably another seminar worth of discussion. Okay, so when we're presenting and talking about relational analysis data, it can be really beneficial to display the strength of those relationships in numerical form, give some sort of reference point, basically. So for example, we can use probability as shown in this diagram here, where 0 equals there is no relationship between concepts and 1 is a direct relationship. We can also report frequency, but there can be some problems in this. And one of the reasons, or one of the things to consider with relational analyses is that there is sort of two relationships happening here. So for example, if we have sort of two concepts that we're looking at relating, the number will be different for each of them. So if there's a frequency of 100 of something and then 10 of the other, and those things are related 10 times in the data, then one of those concepts will have a relationship of 1. It always happens. So 10 out of 10 times it happens. And the other one will have 0.1. So 10 out of 100 times it happens. So we need to be mindful of this sort of thing when we're reporting the relationships in the data to make sure that we're not overstating a particular type of relationship and also giving importance to the wrong concepts. Okay, so another thing, and I've mentioned this a little bit before, and I'll probably continue to say it, relational analysis really need to be driven by your research question. If you're not strategic about what you're looking at when you're doing relational analyses, you can end up with a huge amount of data and it can be a very trial and error process, which is generally not a good approach to do things. It can be very time consuming. So here is an example of just a small segment of data that gets exported from a relational analysis. And this is just two concepts. So there can be a lot of data to sort of look through and then interrogate later on. So be mindful about what you're aiming to do and what you're trying to answer so that you can be strategic about your analysis. Okay, so this is kind of what it can look like towards the end. So we have some diagrams. These particular diagrams are called Finio or alluvial diagrams, and they can be quite effective for presenting matrix style data. And then we have, similar to the conceptual analysis, an overview of what those relationships are and some examples of quotes from the text. Okay, this one here is looking at two different concepts, so two different themes. So we have them on either side. You can also look at relationships within a single theme. So like this here, we have these circle diagrams that are sort of, relating to one another within the theme. So there's quite a bit of flexibility how we can approach relational analysis, depending what sort of concepts and themes you're interested in looking at in your data. Okay, so I guess one really important thing before we move on from conceptual and relational analyses is that it can be a really good idea to think of them as related and sequential. So rather than being mutually exclusive, you can actually basically do both. And it can be a very good idea to do this, to think of conceptual analyses as kind of the first stage, to identify what's important, to identify the specific themes or concepts that are in your research. And then once you have all that data sort of coded and analyzed, then you can go and start to have a look at the relationships between those concepts and themes. And we're able to do this because underlying both conceptual analyses and relational analyses is coding of the data. And if you code that data in the same way to facilitate those analyses, then there's no reason why you can't do both a conceptual and a relational analysis and report those results. So identifying concepts, and then after we do that, identifying the relationships between them. Okay. All right, so there's a quick overview of content analysis and conceptual and relational analyses. We will be looking, I guess, a little bit more about those in terms of how to analyze them and how to export that analysis once we move into the demo of the Atlas software. But for now, we're going to move on to the coding scheme and how to develop coding schemes. All right, so I guess first of all, what is a coding scheme? Well, simple definition is that it's a system applied to data to identify and organize concepts that you're interested in. I've got an example of a coding scheme that I've done in the past over here, so we can see different categories, different concepts, themes, and then examples of those or descriptions. So these are the things that I was interested in analyzing in this research regarding airport security, was the context here. So once we have a coding scheme like this system that we're going to apply to data, the actual coding of textual data is very similar to annotating a document or commenting on a document like you would in Word. So we basically take these categories or themes that we have in the coding scheme and we apply them to the text. So we can identify where they are, quantify them, and then form relationships later on. This is an example of what some coded text looks like. So like I said, very much like commenting in Word. We have the text that we're analyzing, and then on the right-hand side, we have these sort of bars which show where those codes are assigned in the text. Okay, so when we go about developing a coding scheme, there's a few things that we need to think about. And here it is again, we need to be mindful of our research question. Okay, so, and the reason we need to be mindful of our research question is that a coding scheme can get out of control pretty quickly. It can become this massive thing that becomes really hard to apply. So if we're thinking really intently about our research question and exactly what we want to answer, then we can actually code selectively. So we're not capturing everything in the data. We're just coding what we need to answer our question for our research purpose. And this will enable us to be more focused in terms of how we identify importance and meaning in the data that we're analyzing. So once we get past that step of being focused on what our intention is with the research, we can then look at how we go about developing it with a couple of different approaches here. So there's three general approaches: deductive, inductive, and hybrid. And over the next couple of slides, I'll break down these and give you some examples of how you can go about making these. Okay, so first of all, we'll start with the deductive approach to developing a coding scheme. So the coding scheme developed deductively is basically top-down development. So this is where we take predetermined concepts and then we basically put them together into our coding scheme. And those predetermined concepts can be from a range of sources. So it could be from your literature review. You could be reading a variety of literature and you identify specific theoretical concepts that you want to relate to your research. Or there might also be a specific theoretical framework already in place. So you might want to apply a specific theory to your own research. And when this is applicable to do, so when we want to take a deductive approach, it's typically because there is a particular theory underlying your research, or you want a specific theory to underlie and explain your research. We might want to test the applicability of that theory to your research context. So you might be performing some research in a very specific context, for example, an activity context, and you might want to try to explain what you're doing or see if the actions that are happening in that context can be explained by a specific theory. So this sort of builds on, or the next point builds on that. So explaining phenomenon that you identify, things that you see in your actual research context by this existing theory. And this can be quite powerful because you're essentially sort of building on an existing theory and applying it to a new context. It can also be very important and beneficial for discussion of results because you have something there that is already sort of built that you can sort of scaffold your own research with. Okay, so how do we go about developing a coding scheme deductively? Well, I mean, it generally just involves a lot of reading. So we're reading literature, we're reading documents, and we're sort of extracting and identifying codes and theory that are relevant to your research context. I kind of alluded to this before, so you may already have a complete theoretical framework laid out for you. An example of this might be some established emotion scales. So how people feel, how we sort of distinguish different emotions. If you're looking at someone's emotional experience interacting with an environment, for example, that could be applicable. It also may require you to sort of, I guess, trawl through literature and then identify and assemble it into something that makes sense for your purposes. And the reality is that you're probably going to be doing a combination of these things because you might not have, not all codes that you identify or not all concepts in the theory that you're sort of reviewing and looking through might be applicable. So you're going to have to do some filtering down. So this is a very iterative process. So that filtering down process is sort of an iterative stage where you might lay out what's important and then sort of chip away at it, combine things. And there's kind of three different stages to this. So the first stage is the descriptive stage. And this is kind of where you might have a theory or something that you're wishing to apply to your research. And then you sort of look at your data and identify what is important or what is relevant rather. So this is, you have to be quite objective and self-explanatory in this stage. So explaining concepts in your data and then relating those to different areas of interest or existing theory in the literature. Okay, so the second stage is applying interpretive codes or developing interpretive codes. And this is where you're sort of chipping away or filtering down. So you're applying your codes more meaningfully in terms of how you're labeling them. And this might involve merging codes together that might be similar or getting rid of codes altogether. You also might deconstruct some concepts into more fine-grained codes, so to represent more detail in your data. And this process very much involves sort of a synergy between understanding the theory that you're trying to apply and being very familiar with the data that you're analyzing. And then the last stage, pattern codes, is really an analytic step. So this is where you're really applying those codes in the data and looking for relationships and patterns. And with software, this often occurs sort of automatically. So for example, in Atlas, this sort of pattern coding can be a process that's applied in the data, whereas other software where you're sort of establishing relationships based on sort of your own inferential understanding of the data might happen more manually. It very much depends on the sort of data that you're using and the software that you're using, I should say. Okay, so this is an example of a deductive coding scheme. So in my PhD research, I was looking at airport security screening, and I was looking at expertise development in that environment. So how people developed expertise and what was underlying that. And as part of it, I was very much interested to identify what sort of knowledge security screeners were applying to help them in their task. So I developed a deductive coding scheme, or part of a coding scheme that was deductive based on knowledge quality and knowledge type. So you can see here different knowledge types, different qualities, and then sort of descriptions. So in practice, there is a lot more knowledge types than this, but these 4 and with 8 different qualities assigned to them described what I needed to in my research. And that was a process of going through those sort of stages of sort of identifying what might be relevant, and then sort of through data interrogation, identifying kind of what was really important for my coding scheme, so I could be very focused in terms of what I was looking at. Okay, so let's move on to the inductive approach. Okay, so this is essentially the opposite to deductive, where we're developing a coding scheme from a bottom-up approach. So we're looking at the data that we have, the data that we've collected, and we're identifying codes within that data or based on that data. Okay, so this is applicable for a number of reasons. So it enables identification and analysis of important concepts in your data that are specific to your data. So these concepts can also be a little bit more explicit because they're present in the data, whereas some theoretical concepts can be a little bit more abstract. So they're not necessarily explaining what is happening in the data, they're sort of explaining at a higher level, I guess, qualities of what is in the data. So an inductive coding scheme where you're looking at concepts that are based within the data is a bit more explicit to your research context. It also prevents theory from over-defining your research. So it's allowing you to sort of add your own flavor to build theory. And in fact, it facilitates the creation of new theory where you can expand on theoretical concepts with findings in your own research and themes or concepts that emerge from that. So it's really important for new knowledge development. Okay, so how do we go about doing this? Like most things, also involves a lot of reading. So you really need to systematically review your data. So you have your transcripts or even just raw recordings at this point, and you'll listen to those and really just read over them and start to identify concepts and themes that are present in the data and relevant to you. So you can think of this as a fragmenting process where you have your whole data put together and really sort of breaking it down to identify what is in there to begin with, and then assembling it so you can identify what's important. Now, the actual process of sort of developing a coding scheme inductively shares a lot of similarities with deductive approach. So it's very iterative. So we start initially with open coding, and we can do this within software or outside of software. My preference is to do it outside of software. It seems to be a little bit more quick and flexible. So this is where we're just reading through or listening to our data and noting down concepts that come out of the data as they emerge. And we're not being particularly selective at this point. We're just aiming for sort of speed and volume, trying to get as much possible out of that. We're not organizing anything at this point. We're just generating ideas or concepts that we see, we read or hear in the data. Okay, the next stage is axial coding. And this is where we start to take those many concepts that we identified and wrote down, and we start to group those into themes. And when we're putting those into themes, you'll notice a lot of repetition. So concepts come up multiple times or similar concepts arise. So it's really about combining those together. Okay, so then in the last stage, this is where we're really applying those codes. So we have come up with a coding scheme in axial coding. We've sort of put something together that is refined and grouped. And then in the selective coding stage, we go ahead and we start applying those codes. And it's very rare that you get a coding scheme right on the first go. So as you're applying your codes to your data, new codes are going to emerge. You might combine things, you might expand and add extra codes or themes. You might even do a little bit of restructuring. You might move things around so that your coding scheme works a little bit better. So throughout this process, we need to be flexible and objective. It can be, sometimes it's better to abandon a coding scheme altogether and start again rather than try to get one that's not working initially work. A good approach sometimes can just be to expect the first one to fail, and then you're not too worried when it does. So this is an example of sort of the open coding stage. So just, identifying things that were in the data on post-its. And after we've sort of put this together, arranging it into some loose themes. But within those themes, we have a huge amount of repetition, too many concepts. This is much too large for a coding scheme. Okay, more. There's even more images as well. And then from that sort of open coding stage where we're just identifying themes and concepts, we're starting to revise those down into some specific themes and groupings that are useful to the research. So in this case, we have sort of a heading, sort of the theme, and then the content or the codes within those themes. So process of organization. And this is why post-it notes can be really handy, or using something like Miro, for example, like an online collaborative tool. Because at this stage, when you're just identifying concepts and then trying to group them together into a theme and build your coding scheme, to have flexibility and agility is quite important. If you start to put this straight away into an Excel spreadsheet, it'll just be like a copy-paste nightmare. So I think working analog at this point is really effective. And then once you've sort of got something that you think will work, that's when you can move it into the software or into Excel if you want to organize it. Okay, so as well as inductive and deductive approaches, there's also a hybrid approach. And this is where we combine a deductive and an inductive approach together. So we need to, just like conceptual analyses and relational analyses, coding schemes are not mutually exclusive. So we can combine them, and it is very common to do this, and it's hugely beneficial as well. And I alluded to a little bit of this earlier on, but basically if we combine these approaches, so if we take some theory within our coding scheme and we combine it with sort of a grounded approach where we're identifying concepts inductively from the data, then we can start to explain the phenomenon in our research context, so the inductive concepts that emerge by applying established theory. And this can be a really good approach for a relational analysis. So you can basically provide meaning to theoretical concepts by applying your inductive concepts, or you can do it the other way around as well. And it's also really useful when we're discussing our results in a broader theoretical context. So if you're explaining what was important in terms of the inductive concepts in your data, then you have that theoretical backing of codes that you've applied deductively to provide additional meaning and discussion, to build on and expand on previous knowledge and create your own new knowledge as well. Okay, so this is an example of a deductive hybrid coding scheme. So I showed this just before, but I'll sort of take you through this. So this is again relating to some research I did with airport security. And basically what I was talking to security screeners about the sort of activities that they were doing, which is over here. So they were basically telling me what they do on the job, where they're searching for objects, examining images, using the interface, talking to other security screeners. During these conversations, they also spoke a lot about context, the types of objects they were looking at, or the concepts within the images that they were looking at. Excuse me. So these were the inductive elements that I extracted from the texts that I was analyzing. So the types of activities they were talking about, and then the details, so objects, concepts, and the context. And then I also applied the deductive coding scheme component of knowledge, type, and quality, which I talked about a little bit earlier. So in this case, I ended up mapping how knowledge, type, and quality related to different actions and the context that those actions were performed in. So we could explain not only what security screeners were doing at different levels of experience, but the knowledge underlying that and how it developed as well. And that's really the benefit of using a hybrid coding scheme. If you're just using sort of an inductive coding scheme, you might sort of limit yourself to only explaining what you're finding in the data. It might only be a very conceptual style analysis, whereas you start to bring them together, then you have more opportunities to look at relationships between theory and concepts. All right, so we're gonna, so that's kind of the approaches to developing a coding scheme. It's a process. It takes a bit of time, but I think as long as you're sort of rigorous about it and considerate of what you're sort of looking for, you can be kind of hassle-free in some respects. But there is a couple of things that we really need to consider when putting them together, and that largely comes down to the structure of a coding scheme. So both inductive, deductive, or hybrid coding schemes are very iterative. So they're evolving, they're expanding and contracting. So as you're sort of developing, you're trying to usually remove information from them. And then as you're sort of coding data, you tend to be adding stuff back in because you need to explain it. So as you get more familiar with the data, and also focus more on your research question, your coding scheme should become more and more refined. So you basically want to have it so that there's no redundant elements, but it's efficient enough to explain all the concepts and all the theory that you need to within your data. So you're trying to find that sort of happy balance between those two extremes. So it's really important that early on we're thinking about how we're structuring them so that they're appropriate for what we want to find out, and also the types of analysis that we want to do. So from the very first stage of developing a coding scheme, as you're sort of putting together those post-it notes and sort of categorizing them into groups, you're starting to structure your coding scheme. You're basically applying structure to it. So there's a few things to keep in mind. So some of these are sort of things that I've just found out the hard way by doing this and then having things not work, but some of them are quite well-established ideas. So, okay, so the first thing I guess to consider is that coding schemes typically involve multiple levels. So they're usually hierarchical, at least in some sense. So you have sort of categories, you have codes, you might have subcodes. You could have other levels as well, although it's probably not advisable. So there is a hierarchy, an implicit hierarchy when you're putting together a coding scheme. But those hierarchies, they can be functional or they can be simply organizational. So an organizational hierarchy is more or less one that we're using a hierarchy to just organize codes under subheadings or themes or subthemes. Whereas a functional hierarchy is one that functions different based on hierarchy in the software. So software plays a really big role in terms of how we're putting together the coding scheme in terms of hierarchical versus non-hierarchical. Okay, so let's talk a little bit more about these in detail. So a functional hierarchy or coding scheme in a functional hierarchy, it kind of looks like this, where we have sort of different levels. So we might have categories, subcategories, and then we might have the specific codes within them. And if you're using them as a functional hierarchy, and this applies to certain software, so for example, in Vivo, you can code in functional hierarchies. It basically allows us to code at different levels. So if we have a hierarchy like this, we can code at 3 levels. We can code at the category level, the subcategory level, and the code level. And basically what this sort of implies is that the upper levels include all of the information of the lower levels. So if we code this subcategory, we're in essence reflecting all the information in this sort of block here. Okay, so in other software, the hierarchy is simply there for organization. And this is applicable to Atlas.ti. So Atlas.ti is very much a non-hierarchical type of coding scheme, coding software. So this is more or less how it works here. So you develop a coding scheme that is very flat. So this is where all codes exist on the same level. But we can apply some strategies so that we apply some organization and hierarchy to these, but at no stage are we functionally coding at different levels. So the information we're coding is always at this bottom level, so we can only code at the level of the codes. So to organize these, we can apply some prefixes to them. So these are usually in text in the coding scheme. And I'll demonstrate these once I jump into the software. This might seem slightly abstract at this point, but hopefully it'll make sense when we jump into the software. And basically what this allows us to do is code at the code level, at this singular level, but also have the information of those upper levels present here. Now, whether or not we go for a functional hierarchy, say in vivo, or an organizational hierarchy in pretty much any of the coding softwares, is kind of, I guess, up to what you want to do with your research. I think a general consensus is that it can be really beneficial to keep the coding scheme flat, like we have here. So coding at the code level only. And the reason for that is you can always go up, but you can never go down. So if we coded at sort of a category level to try to include all the information of the codes below it, we're not going to be able to have any sort of fine-grained understanding of what we're coding there. It's very sort of overview level. Whereas if we code at this level, if we coded one of the codes and we have these prefixes in place, we can sort the data and we can identify whether it falls underneath the subcategory or category. So what this also does is it encourages us to make decisions when we're coding, and this is a really important thing, it's probably a sign of a coding scheme that is well structured and well designed. If you can make choices with a good level of confidence about what codes you're applying, then you probably have a really nice coding scheme that doesn't have a lot of redundancy in it. It's not too large and the concepts are specific to what you're looking at. If you're wanting to code at a much higher level, so at a category level or subcategory level, then it's possible that there's some ambiguity in your coding scheme. So you're not quite confident about what you're trying to do. So structure a flat coding scheme using prefixes so we can apply some organization to that. Again, I'll demonstrate that. You can also apply supercodes to group codes in Atlas. I'm probably not going to touch on that in this presentation. It's something that I don't particularly find that useful because most of the analysis you do in Excel anyway, where those supercodes are kind of not as appropriate or not as applicable. Okay, so it's very important that we avoid very large and granular coding schemes. And this is a very common mistake coming into developing the first coding scheme. It's very tempting to try to keep as much as you can in there and explain as many things as possible, explain everything. But it's really not advisable. If it's too large, it can be really hard to manage. So we just might simply forget what codes we have. And this can be particularly true for theoretical coding, where you're trying to apply sort of an abstract theory to specific content in your coding scheme. If you have too many theory or too many codes, it can just be really hard to understand or remember them. Okay, so if a coding scheme is too granular, so too fine a level, it might also include ambiguity and redundancy. And this is really important that we avoid this because it can be difficult to apply codes that are ambiguous. So this relates back to having certainty in what you're coding. If there's any level of ambiguity in a code, or you're weighing up between two very similar codes, that makes it hard to apply those codes in a consistent manner and ensure repeatability. The last point here I have is having many codes can just be really difficult to report and write about. So, eventually we're turning this data into a thesis or a paper, and we're very much restricted to an A4 piece of paper. So if you have hundreds of codes, trying to explain all those to someone can be extremely challenging. So it's better to try to get those down to something that's more manageable that you can explain effectively. So aim for just enough in relation to your research question in the content area. So we want to be able to describe everything to a good level of detail, but also have a nice, concise and agile coding scheme that we can apply easily. Okay, avoid similarity. So this sort of builds on ambiguity. If you have codes that are too similar, then they're going to be ambiguous. So often we're subjectively interpreting our data and applying codes to them. So there's some level of subjectivity in there. And if you have very similar codes, then there might be just no consistency in terms of how you're applying them. You also want to avoid repeated codes in two or more categories. So this is a sign of a poor coding scheme structure. If you have the same code in multiple categories, then you probably haven't refined the coding scheme down to a good level. Okay, so relating to the size of the coding scheme, if it's too large, if you're finding that you have a vast number of codes, if you feel like it's too big, then chances are there's some similarity in there. So it's a good idea to go back and really review that and identify what is similar and what is not. So what we're aiming for really is a coding scheme in which the codes or the concepts that you're trying to capture are differentiated and they have clear delineation between them. So you want to have a high level of certainty of what you're applying. And for that, you need almost no ambiguity and very little similarity. Okay, objectivity and subjectivity. So as I touched on, there's always going to be an inherent level of subjectivity in coding schemes. We're looking at data, we're reading through data, and we're making a judgment about what the content of that is and how a different theory applies. But some codes or the categories of codes can be more subjective than others. So typically theoretical concepts or abstract concepts that you might get from the literature, there's sort of a level of complexity to these. And usually you're sort of reading your data and inferring from what's being said, what different theoretical concepts are applying. So this tends to be a reasonably subjective process. So we're looking at longer phrases or passages of texts, sentences, and paragraphs that we need to interpret and then assign a code to. On the other hand, words or statements, if we're coding a specific word or a specific thing, a name or a place or an object, for example, this can be a lot more objective because those words or those concepts are explicitly presented in the data. So we might be coding at a smaller level here. So rather than coding sentences or paragraphs with abstract concepts, we're coding sort of just specific words or phrases. I think it can be a really good idea to have sort of a mix of these, and this really links back to deductive and inductive approaches to coding. So if you have these inductive or more explicit concepts that you're coding, this can ground some of those more theoretical, more abstract and more subjective ideas that you're trying to look for in the data. Okay, so that sort of brings us to an end, I guess, of the sort of the overview and the PowerPoint stage of this presentation. So I'm going to now jump into Atlas and just sort of give you a bit of a demo of how we go about, I guess, bringing in a document, applying some codes, and then running an analysis. All right, so before I jump in to Atlas, there's a couple of things I do want to touch on that are really important for applying codes. So I guess up until this point, I've kind of shown you coding schemes, what they look like in terms of just categories, subcategories, and specific codes. But obviously behind just identifying these single words or names is a whole lot of thought process and thinking and analysis. So one of the really important stages or parts of this, putting together that coding scheme and getting ready to start coding, is the development of heuristics. So these are sort of simple rules for the application of codes. And these are really important for a number of reasons. So, I mean, for you personally, when you're working in your coding scheme, it provides sort of a system or a series of guidelines or rules for applying your codes. So this is particularly important for applying theoretical concepts. So you might have heuristics that are based on descriptions of what that concept relates to in the literature, and you sort of put those together. So this is an example of some heuristics that I've put together for knowledge type and also processing style, so level of intuitiveness. So most of these are based on points from the literature that I've identified. Now, having heuristics, it's also really important for demonstrating repeatability. So if someone else were to take your coding scheme and apply it, they could refer to your heuristics. So they have your rule set for how you applied your coding scheme so that they can apply it in the same way. And also going through this process of developing heuristics is really important for eliminating similarity and redundancy. So when you're sort of evaluating your codes and putting together these heuristics, it really becomes clear when two concepts are too similar. So you can merge those or discard one if necessary. Okay, so then once we have sort of our heuristics and our coding scheme fully in place, our strategy or our approach to coding depends on a couple of things. So, I mean, the coding scheme is really a determinant. So coding single words or short phrases, so explicit or objective concepts, versus coding full sentences or paragraphs, for example, inferring subjective concepts. So there might be different approaches for different levels or different categories within your codes. And then also really important, we need to think about how we're actually going to do the analysis. So you need to kind of be thinking multiple steps ahead at this point. So if you know you need to do a relational analysis, for example, you need to not only be accurate in what you're coding, but you need to ensure that you're capturing those relationships in your coding strategy. If you're simply looking at a conceptual analysis, then it can be a little bit simpler. So you might not be thinking too hard about whether you're coding for overlaps or co-occurrences. So a couple of things to really think about in that respect. Okay, so let's now jump into Atlas. Okay, so during this stage, I guess for the last 50 minutes, I've just been talking to this screen. If anyone wants to ask questions while I'm sort of working through Atlas, I'm happy for you to do that. That is absolutely fine. Okay. Let's create a new document. I guess one of the unfortunate things about demoing coding is that most of the data that I have is, I can't show you in raw form due to ethics. So I've kind of created some dummy data that we can have a look at how we code. All right, so this is the Atlas interface we have here. And I'm just gonna move that so I can see. Okay, so the first thing that we need to do is we just need to add some text to it. There's a couple of ways that we can go about doing that, but I'll show you an approach. So in the Documents tab, we just have, we have the New option, and here we can do a couple of different things. So we can import a transcript. So if you have a text file, you can bring that in. You can also create your own text document. So you can just copy and paste some text into the workspace. So that's what I'm going to do. And give it a name, usually a participant number, something that is identifying what your data is. Okay. So once we have that, we have essentially a space that I can bring in some data. And we can just paste that in. Okay, so once we have it in here, we need to put together a coding scheme. So at the moment, we just have text. We haven't got any codes or anything like that. So we need to go about doing that. And again, just like bringing in a document, there's a couple of ways that we can go about doing this. One of those ways is to click on the codes menu and then go to the code manager. And that'll bring up this sort of box here, and we can start to create some codes. So I've got this coding scheme here that I've quickly put together. So I should probably give some background about this data I have. So this is basically asking someone about products they use, what makes them use them, what they like, and how they use them. So I have this coding scheme that I've kind of put together pretty inductively, but also with a deductive element to it as well. So there's some objects that the participant identifies. There's some product attributes that they identify. They talk about the origin of those products and some actions that they perform on those products. And then we have the deductive element. We have sort of the pleasure that that person shares with that product. So socio-pleasure, physio, psycho, and ideo-pleasure. So these are from literature, and we're going to apply all these together. So I'll move that to the side for now. Okay, so to go ahead and make that coding scheme, we can come in here to our code manager and just create a new code, and we can basically just list them out. I'll just put a couple in here. All right, so that's our object codes, and now I'll put in some product attributes. Okay, that'll do for now, and then if we press OK, they'll populate into our code list here. Okay, so now I sort of put them in this way because I wanted to show you one of the problems, I guess, with Atlas and the way that it manages codes. So if you remember from the presentation, I mentioned that Atlas is a very, it doesn't have functional hierarchies in the coding management system. It has a flat system where all codes exist on the same level. So we can see here, I put in those codes and I made them as different, I guess they were from different categories, but I put in coffee maker, headphones and phone, and then also from the product attributes, I put convenient, easy to use and effective. So what it's gone and done here is it's just organized them alphabetically, which is not great because if we want to then apply some codes to this text, it becomes quite difficult for us to find what we want once we sort of populate that whole code. So we might be coding for a specific category, not just simply in this flat structure. So you can actually apply some families to these. So we can go to families and open family manager. And here we can basically create a family. So object, let's create product attribute. And then we can essentially select object and then select these and bring them over. And we can do the same thing here. Okay, close that. Go back to our code manager. And then we can sort of filter and sort like this. So that's one way to do it. And I still don't necessarily think it's the best way to do it. So my preference is you can put them in families. It can be useful later for analysis. But one of the most effective ways to do this is to use prefixes. So I mentioned this in the presentation. So we can come in here and we can rename this code as, so this is from the object category. So we put a prefix in, so OB, coffee maker, and we basically go through and do this for this whole process. Yeah, and same thing. So I'll just quickly do this. Product attribute. Okay. So then when we, okay. And then when we actually go to to apply codes, it becomes a little bit easier to sort of find and identify these. So, all right, so when we go to apply our codes, if we come in here and we start to look at them, look at this response. So for example, if we read this first line here, product that I use every day or almost every day is an old coffee maker I have. So we can select that. You could select the whole sentence there, or you could simply select coffee maker if you wanted. And then we select the code list, and then they'll be arranged based on the prefix. Okay, so we can have that present, and then we can select coffee maker. The other way, so when we actually code this, it basically appears on this side here as a comment. So we can go ahead and unlink that to keep that if we wanted, if we accidentally coded the wrong thing, or we can delete the whole thing. The other way we can code is if we just simply highlight this section and then we click the create or assign new codes to the current selection. And we'll basically get a search box. And this allows us to actually create a new code. And or we can just simply type in, start typing, and it'll come up with everything with that prefix. So we can apply coffee maker here. And if we wanted to apply more, we can do that as well, but we're only coding sort of one code here. Of course, with Atlas, there's always a number of different ways that we can do things. We can come back to our code manager, and if we, for example, down here, let's go phone. We can grab the code and drag it and drop it, and it'll apply it as well. So there's a couple of different ways to do it. My preference typically is to use the open coding function, because often that's what you're doing. And generally speaking, when you see a code, you kind of know what you're wanting to apply, and you can just search for that and apply it. So for example, where are we? Sure, let's see. This code here, this person's talking about taking this coffee maker to South America, and having this code was very handy because all you needed was a stove, water, and coffee. So we can apply this. So this is maybe a product attribute. It's convenient. But we're also talking about the object coffee maker. So we can apply two codes from different categories to that section of text. Okay, so that's sort of coding codes that I've already applied or added to the coding scheme. And this button we can use to also create code sort of on the fly or as an open coding process. So for example, let's look at this section here. This person they were talking about, they were very popular with others on this trip because they could make a good cup of coffee anywhere. So in this case, we might want to apply our theoretical concept of a socio-pleasure, so gaining pleasure from the social experience that a product elicits from with others. So we haven't actually added this concept to our coding scheme yet, so we can just click the open coding button. And then here we can add that in. So this is a pleasure, so we'll create a new prefix for that, and we can type in socio. And then we can apply that. Okay, so what that'll do is that'll actually create that code now. So if we go back to our code manager, we'll see that that code's now been added to the list. So typically when you're sort of applying these codes or working through the codes, what you find is that you might put together a base coding scheme, and then as you sort of start coding, you might identify new things. And typically this happens with the inductive elements. So usually with a deductive part of the coding scheme, you already have that ready and you can apply that. But then when you're coding through, you might identify those concepts inductively, and you're just adding to them and sort of building that coding scheme. And of course, we could add that to a family as well. Okay. I mean, so that's the general process of coding. I'm not going to spend too much more time doing that because I think it would be incredibly boring. But that shows you sort of generally how we can code. So I guess the next thing we need to think about is the analysis, how we can export an analysis once we've sort of coded an entire transcript. And so I can show you an example of that with this data, and I might actually bring up an old project and just show you some of the data output that we can get in terms of numeric, because it's much more extensive than you know, the whatever 5 codes I've added here. Okay, so once we've sort of coded all our transcripts, then we need to run the analysis. And these are pretty straightforward, and we can run a conceptual analysis and a relational analysis provided that we've coded in the right way. So to export some data for a conceptual analysis, we just need to go into codes, and then we go the output here. And if we go into the code's primary document table, it'll basically give us this sort of data export options. So what we need to do here is we need to select all the codes that we want to include in the export. So if you're doing a conceptual analysis, you're probably identifying all of the codes, putting that over here, and then you're picking the documents. So we only have 1 in here at the moment, but normally we'd have you know, many more, and then bringing that over. Okay, so then it's a matter of just creating that report. Okay, so that's going to bring up an Excel prompt like this one here, and it uses an older version of Excel, so let's just say yes to that. And then we'll get an export that looks something like this. Okay, so essentially the breakdown here is we have all our codes down here, and then we have the document, so in this case our demo document, and it shows us how frequently those codes appeared throughout. And then we have a total. So if we had more documents in here, all those would show up in this section if we wanted to know what the total was. So this can be really useful when you're maybe filtering between some independent variables, maybe different participant types. So you can identify which codes were more prominent for different types of participants that you're interviewing or talking to. All right, so let's get rid of that for now. Okay, so that gives us the numbers, basically the frequency. But of course, that's only telling part of the story. So we need to be able to then go back and sort of interrogate the data. Okay, so if we again go to codes, and then we go to output, and then we can select all codes with quotations. All right, so that gives us some options. Let's just choose editor. So that's the Atlas's own sort of editor. And essentially what this will provide is like a rich text format document, and it has each of the codes in sections. So here we have the coffee maker code, the headphone code, convenient code, easy to use. And then underneath each of these, it tells us what document it's in, what codes were applied, if we added any memos, which I'm not going to be touching on in this session today. And then it provides us the text that we've assigned that code to. So this allows us to export all of the quotations. So we can see what the important concepts are, then we can come back in here and really understand those concepts and what makes them important. Okay, so it's not just a matter of coding. Coding is kind of like the first step. Then there's this large stage of sort of going back into the data and really analyzing that. Okay, so that's really sort of the main components of a conceptual analysis, to get sort of frequency and then also revisit the data. And then we can do a relational analysis as well. So to run one of those, we click analysis, and then we need to select code co-occurrence table. And this will give us another sort of selection option. And what we need to do here is select columns and rows. Okay, so so we've only coded a couple of codes here, so this is not going to be particularly interesting. I'll open up another document in a minute and I'll show you something a bit more in depth. So we might select our object as codes, as categories, assign those in, and then we can select our pleasure, for example. Okay, so it hasn't identified anything there, so there's no relationship between those things. So if we look at this, we should have a relationship there. Not sure why we don't. That's interesting. Maybe I got rid of it. Yeah. Okay. All right. So here we go. So I'd need to, so in this case, none of these codes are overlapping. Okay. Except for the object and the product attribute. So if we go back into our relational analysis, product attribute and our objects, and you can see here, because those codes were overlapping, we have one written in here. I'm going to go ahead and I'll open up another document so I can show you one once we have more codes. I won't be able to show you the text in this because it's recorded, but that's okay. So in this case, we have, I think, 40 documents, yeah. And we have quite an extensive coding scheme, as you can see here. All right, so if we go in here and run a code co-occurrence table, so this is relating to the airport security screening example or research that I've done. So let's have a look at our actions. So the different types of actions that security screeners are performing. And let's look at the relationships between that and knowledge. Okay. Then we can put those in like so. So here you can see we have a lot more relationships, so we can really start to see what types of knowledge are associated with different types of actions. So we can see that procedural knowledge here is really prominent and it's related to these specific tasks. So manual searching, object removals, rerunning objects and so forth. So we can see what sort of actions relate to the knowledge and vice versa if we want to explain that. So at the moment, this is just showing us frequency, so how many times these things related. If we come up here to this little C icon, it'll give us a coefficient. Okay, so this will give us the frequency and also basically the probability that they relate. So based on how many times each of them appear, what is the probability that they overlap? And this little yellow icon here is indicating that there is an unbalanced relationship. So I explained that before, that there's always a two-way relationship when you're looking at related concepts. This is basically saying that in one direction, it's much stronger than the other. So this would be, you know, these ones that have these yellow dots on them, these would be something that you would really need to go back into the data and identify the nature of the relationships. So you'd probably look at how many times this code occurred versus, say, for example, how many this occurred, then look at the relationship, the overlap, and then sort of make some decisions about if it's relevant or not. Okay, so I'll just, let's close that for now. Okay, so then if we identify some really essential relationships, we can then come and look at the Code Co-occurrence Explorer. So this is kind of like the feed that I showed you before, which has quotations in it. But this time we're basically looking at relationships, the quoted relationships. So if I'm interested in, you know, the relationship that happens between the activity of a manual search and a specific type of knowledge, let's say this procedural knowledge, we can basically open that up. And here we actually can then find specific passages of text. So this allows us to not only identify important relationships, but then come back into the data and really determine what is the nature of that relationship. So we can start to explain what is happening in that space and provide meaning. So it can be quite a time-consuming process. And again, this is why we really want to be, I guess, strategic in terms of what we're looking at in the data, so that we're not spending huge amounts of time sifting through relationships that really have no meaning. Okay, all right. So that's more or less everything that I wanted to present to you in Atlas. Given the time, I know I've gone sort of 15 minutes over for this part of the presentation. So we can kind of move into the discussion or question time session if everyone's happy to do that.